So we are very excited to have our first special guest speaker, Llion Jones from Sakana AI. Llion was an engineer at Google and also co-authored one of the very famous transformer paper, which made a huge impact to the AI field. He recently co-founded a startup, Sakana AI, as a CTO. And many of us are really interested in his next big challenge. Today, he is here at Tohoku University. I'm really excited to see him in person and have lunch together. Thank you for coming. So without further ado, let's give a welcome to Llion Jones. Okay, take it away.
Thank you. Hello, everyone. I'm going to start by apologizing if I come across as a bit nervous, because I'm traditionally a very shy, introverted nerd that is not at all used to public speaking. So that's why I might seem a bit nervous. First of all, I'd like to thank Suzuki-sensei for the invitation. You know, it's an honor to be able to speak here at the university. And I'm very happy to have a reason to come up to visit Sendai for the very first time. まだ勉強中ですけど、ちょっと日本語で話してみたいです。Sakana AI の CTO のライオン・ジョーンズと申します。母国語、ウェールズ語の名前の発音はリオンです。リオンですが、日本語でライオンと呼んでください。動物みたいですね。ライオンです。今から英語でごめんなさい。どうぞよろしくお願いします。So today there's three things I want to talk about. I'm going to talk a little bit about myself, my background, and then I'm going to, of course, talk a little bit about the transformers. But then I'm going to talk about my work both before and after the transformers that seem to have had a lot to do with character level modeling, and it's an idea that I've been pushing for a while, and I want to encourage people to take that direction. So first of all, I am Welsh. My first language is Welsh. That explains why my name is a little bit weird. I find that it's actually quite difficult to explain sometimes to Japanese people where I'm from, because people hear my accent and they go, you're English. And I have to explain, no, I'm not English. I'm British, but I'm not English. But if you put I'm British, but I'm not English into Google Translate, it says, 私はイギリス人じゃなくてイギリス人です。So it's the same word, it's difficult to describe. So Wales is a very sort of rural country, and I come from a very, very small village, population of 200, so when I was in school, the entire school only had 16 students in it, and there were 3 classes, so, like only a few kids per class. There's a very funny story behind this picture as well. When Windows 7 was released in the UK, it came with its own special set of backgrounds you could choose. And there was like 6 or 7 pictures of very famous places in the UK, like the White Cliffs of Dover. And then this picture was in there. And I think no one would really know where this is. But I noticed it immediately because this is the lake right next to my village. So, clearly the place that I'm from is considered to be a very sort of naturally beautiful part of the world. And but despite starting from a small village, I was able to somehow get a job, with a very large company like Google, and I actually started in YouTube, which is owned by Google, of course. I don't have time to go into the story right now, but I actually thought that I was applying for a job in London, And then only when I got to the final interview that they told me, no, actually it's in California. So I didn't plan to, but I had to move to America. When I was in YouTube, I was happy in YouTube, it was fun, but I knew that my passion was artificial intelligence. So I knew I had to move into research, and then, the nice thing about Google is very easy to move around internally, so I applied to move to Google Research, and the timing was very good because it was in 2015, exactly when the deep learning revolution actually got started. And another part of the story is, I came to work in Google Japan, but the timing was really, really bad because I landed here to start my new life March 2020. I think 2 days before they closed the border because of the pandemic. So not a great start. So as you've heard, I recently quit Google after working there for 10 years. And I've started my own company called Sakana AI. You can see here that we've been very lucky to get some press coverage. So if you are interested in the company, it's quite easy to read us about us in the media. So there's a few meanings behind the name and the logo. First of all, this red fish is we want to swim away and do something different. And what this means is that many people right now are just interested in training large language models and making them as big as possible. And we think that actually there's a better way. If you take sort of nature-inspired artificial intelligence, and the other meaning is like it's a shoal of fish, right? So it's sort of a collective intelligence. So can we make smaller models that sort of learn to interact with each other, or maybe that will be more powerful and flexible than just creating one big mammoth large language model. And another meaning I like to point out is that it kind of is reminiscent of a famous Japanese story called Swimmy, right? So of course I'm most well known for being on the Attention is All You Need paper, the paper that introduced the transformers. And if I'm explaining this to a lay person, then I say it's the T in ChatGPT. That's the easiest way for me to explain what I do. What you see in the middle here is something that I developed at the same time as working on the actual transformer, and it's a way to sort of visualize what the attention layer is doing, when after it's being trained. And I think it was very important to create this visualization because I want to share with you the first time that I felt that we had actually created something special, right? That moment in the project when we thought, okay, now this is something interesting, this is something different. So what this is showing is a visualization of what word is attending to which word, and this is called a Winograd schema, where what it means in the sentence changes depending on the ending of the sentence. So, if you say the animal didn't cross the street because it was too tired, clearly it means animal. But if you change the ending to wide, then that's obviously street. And, this sort of reasoning was a long-standing problem in artificial intelligence, right? There had been decades of research trying to get this kind of common sense reasoning into an artificial intelligence system, right? Because there's so many sort of small facts about the world that you need to know about and be able to reason about. You need to know that animals can get tired, but streets can't get tired. But animals, maybe can be wide, but probably streets are, more associated with that. And when we created this visualization, we saw that without even trying, just as a side effect of training a transformer to translate, this ability of what's called co-reference resolution and ability to do common sense reasoning just sort of fell out of the model automatically, right? So we'd got something that people were trying to do explicitly for a long time, just automatically now that we can sort of get these things to do this kind of reasoning. So another sort of personal story is that this title has become very famous in the AI world. And this has made a sort of a very weird part of my life, because I can't go a single day now without seeing some sort of nanny nanny is all you need reference. And so I'm the one that came up with the title, and I want to tell you about that moment. Because I remember Jakob, who was on the paper, he was my manager, sitting behind me and saying, we need a title. Now, what had just happened around that time on the project was, people might not know that the first version had no attention. It was just deep convolutions. We then added attention in, and then we started doing ablations. We started removing different parts to see how much worse it got. And to our surprise, when we removed the convolutions after putting in the attention, it got better. So it simplified the model. So that was what was on my mind when somebody asked me what the title should be. And I said, I'm not very good at naming papers. How about attention is all you need? And I didn't even know that they'd chosen the title until I saw the first draft of the paper. And yeah, like I said, now it's everywhere. If you look, like if you search for papers on the archive, right, Nani Nani is all you need, there's over 350 papers now that have copied that style of title. And it's so weird to me because it was literally, just as I told you, 5 seconds of my life thinking. You know, if it was going to be so famous, maybe I would have put more thought into it. But it seems to have been, very successful anyway. Yeah, so now I'm going to talk about what I did before the transformers. And of course, that's going to involve recurrent neural networks because that's what the state of the art was at the time. So the first thing is we were working on a project called wiki reading. So this was quite early on. This was like 2015, 2016, just after the deep learning revolution. So, everyone was shifting to using neural networks, and we were trying to see how we could use recurrent neural networks to do question answering. What this project wanted to do is the ability to put in a question, feed in a Wikipedia article, and then be able to decode the answer. But unfortunately, we had a problem back then where these models were word level. So not word piece level, that hadn't been invented, just word level, which meant that a lot of the words in the long tail just wasn't represented in the model. So we had a lot of sort of out vocabulary problems. And we had a lot of solutions to this problem, but I thought it was very natural to try to go straight to character level, right? So if you're reading character by character and decoding character by character, you're not going to get any out of vocabulary problems. So I tried this, but unfortunately, back in 2016, we didn't really have enough data. We didn't really have enough compute to get character level working. So, I had to try to come up with a way of getting it to work. And actually, the solution that I came up with back in 2016 even was to use pre-trained language models. So I pre-trained an RNN language model on Wikipedia, froze it, and then trained another recurrent neural network on top of the frozen language model to be able to answer the questions. And this worked a lot better. So you can see the results here, and the character levels are surprisingly competitive with this pre-training technique, because you have to understand that the character level model will see fewer words than the word level, right, because it gets the same number of tokens. So you can see that it works very well, and because we've thrown away having to tokenize all the words, you get much fewer parameters, with a competitive level of performance. I then got an intern, and we wanted to see if character level modeling actually worked better for other languages, not just English, because we had this hypothesis that languages that are a bit more morphological, end up with more words. So it's harder to have a bigger vocabulary. And again, just going to character level sort of simplifies that problem. And I kind of think that Japanese might be similar because there's a lot of conjugations you have to do, so you get a lot of different words from the same word, if you know what I mean. And we did indeed show that it works better, and that character level is more of a win with these sort of morphological kind of languages. So a point I'd like to quickly make is, the world doesn't seem to have moved onto character level, despite the fact that it seems like the natural and the more easy solution. And I think one of the reasons is because we are way too English-centric, right? Going to character level for English is much more of a problem than it is for Japanese, right? So here you go from, 5 words in Japanese to 7 characters, but you go from 5 to 27 in English. So because the sort of state of the art is in OpenAI, that's why they don't want to go to character level. But a company like Sakana AI, right, which is a Japanese company, and we're going to put Japanese first, which means that we will be much more happy to go and try to do character level. So I'm going to now talk about some research I did after the Transformers. And, I basically went back to my interest, which, as you saw, was character level language modeling. And actually, this paper that I worked on, I was actually working under Ray Kurzweil at this time, if you know who that is, so that was sort of an interesting experience. So progress in character level language modeling around this time was actually quite slow because it was RNN based. Like, people are struggling to get more and more performance out of RNNs at the time. And you can actually see that, going from 1.25 to 1.24 to 1.23 was actually a publishable result. Like, that was considered progress. But in this paper, we showed for the first time that if you take a transformer instead and you make it very deep and you do language modeling on a transformer, it actually works much better, right? And this is the paper that basically encouraged the AI community to switch from recurrent neural networks to using, for the first time, very deep transformer language models instead. And then, then from there, you get the evolution to the first sort of GPTs, and you end up with, the GPT-4s. So, the thing I'd like to point out is I think it's interesting that, one of the first papers that did language model pre-training, character level, right, and the paper that moved people to transformer language modeling, character level. So I've been pushing this idea for a while, and people still are not listening for some reason. So I'm going to now show you some research I did in Japan and how character level was a very natural fit for this problem. So I don't know, how noticeable it is to the Japanese population, but the pronunciations for place names in Google Maps was actually quite bad, I'd say, a couple of years ago. And that was my job in the Google Shibuya office, was to work on fixing these pronunciations. And it's a really difficult task because it's almost arbitrary. There's a place in Tokyo called Nihonbashi, but you go to Osaka and it's all Nipponbashi. Why? Or the same kanji as Shibuya in Osaka is Shibutani. Right? Why? So the way it worked actually is we got character level transformers to look at both the place name written in kanji and the neighbors so they could see the kanji and the way that the Google Maps data thought it was pronounced, right? So it sort of took evidence from the neighbors. So you can imagine that like the pronunciation of a small shop is maybe not so likely to be correct, but a big park nearby is correct. So if it sees the same kanji, it can sort of move, you know, that pronunciation into the pronunciation of the shop. So I really do hope that at least some people in this room have noticed that the pronunciation has gotten better recently. And, you know, the project that I was on is to thank for that. But yeah, the main point is you can imagine that you really need direct access to the kanji and the individual hiragana when doing this sort of thing, right? To get the sort of pronunciation and looking at like the differences between the kanji reading. So, you know, this is the sort of reason why I think, you know, character level language modeling is just sort of natural for a lot of tasks. So yeah, so this is just what the model looks like basically. And yeah, so we're feeding in all characters and getting out characters here. So now I'm going to move away from my research a little bit and talk about other people's research in order to highlight some sort of issues with the current language models and the strengths of character level. So this is not a paper I was on, but I've underlined Noah Constant because he was on the paper that I just showed you with the deep character level language modeling paper. And, you know, you've probably seen these image generation, and you've probably noticed that they can't spell very well, right? I mean, you can see maybe kind of, right? Canada is Canadaya, and Colorado instead of Colorado. But here's the thing, right? I think here's what people maybe don't understand. The fact that it can spell at all is kind of a miracle, right? These language models have never seen how words are spelt. When you're training a large language model, it doesn't see the characters. It sees word number 53, word number 5,461, right? So I think this is a really, really good example of how powerful these models are, that, you know, despite the fact that we don't explicitly give it this information, they're still powerful enough to extract this information from the training data, right? So if it can do this, if it can somehow work out how to spell words without never seeing explicitly how to spell words, so think how powerful it is to sort of extract other things. And, you know, the result here I think is kind of obvious but interesting to point out. If you use a character level language model in order to do the image generation, now it can spell, right? Now it doesn't have to do any magic of like somehow learning. It just has access to the characters, so now it can spell. Something interesting is, you know, even if you still use word level, this miracle of somehow learning to spell does get better with scale, right? So you can see that in the beginning here, it can't spell at all. Once you get to 3 billion, okay, kind of, and then 2 billion seems to be enough that it can now spell, which is why some people say scale is all you need, right? So another example of a failure mode that is caused by not being character level is, you know, people will criticize language models for not being able to do a particular task. And they don't seem to understand that the reason for this is the way that they're trained. You know, you ask it to reverse the word lollipop, well, if it can't see the characters, it's not going to do very well, right? But again, this is almost not like a criticism. It's amazing to me that it can it can kind of do it, right? And that shows the power of these models, not a weakness. But if you go to character level, then it works much better. So this was state of the art when I make these slides. I think this is slightly out of date now, but this was like the newest version of DALL-E when I made the slides. And, you know, state of the art, and it still can't spell, right? Because they're clearly not using character level language models. And, you know, like I said, I'm still in the middle of studying, but I don't think those kanji exist, do they? And, you know, that's another point, that in order to get these things that maybe can do kanji, you probably need to concentrate on the Japanese language, right? And so this is another way we're going to differentiate ourselves at Sakana AI. So yeah, so the conclusion is, I think character level language modeling will be here eventually. We will have enough compute to do it, and it'll just be natural because it's much simpler. Maybe we'll go straight to byte level, but you know, that sort of model I think is what's coming. You can see it fixes a few things, and I definitely think that this sort of model is particularly good fit for the Japanese language, you know, which is why one of the things I'm going to be pursuing in my research is applying character level to you know, Japanese language problems. 以上です。
Right.
ご清聴ありがとうございました。
Perfect, yes.
ご質問はございますか?
Yeah, we are going to have any questions from audience and from YouTube. By the way, the talk was really interesting technically, as well as, you know, the backstory of, you know, how the title was made and your hometown and stuff like that.
How about the other languages? Do you have any? Japanese is good. Maybe it's understandable. How about the other countries' language?
Yeah, good question. So the way that I'm thinking about this is that English and Japanese are very different. So if you can get something working on both, I think you can get a high confidence that you can get it working on other languages.
Okay.
You know, I think once we get some good results in Japanese, maybe other Asian languages is a good direction. And I'm actually thinking that to prevent me from overfitting to just English and Japanese, I am going to do some stuff in Welsh as well, because that's my first language. And that's a really difficult mix, right? Especially since Welsh is sort of a low resource language. And then, you know, because we start thinking about, okay, low resource languages, I know that there's a push with the Japanese government to try to help the Ainu as well. So we've also been thinking about, you know, maybe in the future being able to do some work with that sort of language.
Oh, it's very, very interesting motivation. Thank you very much.
Any other? Oh, yeah.
Okay, thank you so much for the great talk. So I'm a researcher in the computer vision, but I'm interested in the natural language processing field. So my question is that currently the word level or token level language model is dominant, but do you have any ideas to further improve the character level language model to outperform the current like word or token level language models?
Yeah, so, you know, that's going to be the research that we're going to be looking at. So one thing I can talk about is that even with word level or word piece level transformers, there is a lot of wasted computation, right? And this gets even worse with character level, right?
Yes.
Some characters are very difficult to predict, and some characters are very easy. And I think you shouldn't use the same amount of computation on both. So trying to think of ideas of adaptive computation, I think, is going to be very important to try to get these character level models working.
Yes, but in the case of the word level language model, the tokenized word, it itself already has a meaning, right? Semantic, right? Like love, school, or things like that. Each word has already like a meaning or semantics. But in the case of character level language model, we have to make the model to like build word level meanings and sentence level and whole sentence level, things like that, hierarchical like architecture, things like that. So then in my intuition, simply applying the transform model to the character level processing, it's kind of hard to build such hierarchical like structure, things like that.
Yeah, I think I disagree. I think the transformer is already very good at hierarchy, right? Even if you look at word level, there is some evidence that the first few layers is actually doing tokenization, right? It is actually putting together the relevant things. If it sees United and States, there's a part that will then represent United States. So you are right that it's a much harder problem because we're starting from lower and we have to build a hierarchy up. So maybe you need a deeper model in order to capture a deeper hierarchy. But it seems to me that it's already powerful enough in order to do this sort of hierarchy. Even character level language models do seem to have a very sort of high level understanding of concepts. So I think it is able to construct this hierarchy already.
Okay, I understand. Yeah, thank you so much.
Any other questions? Can I ask one follow-up question to his question?
Yeah.
Okay. So, yeah, his question about word level, character level, and recently some tokenizers uses like a byte fallback thing. One character is decomposed into several bytes, and then you have also worked. You introduced the part of it, and then I'm just curious your point of view for that kind of approach. Byte level, even smaller than character level.
Yeah, eventually I'd like to see byte level become the standard. I think there are papers recently, megabytes, for example, showed that byte level language modeling works very well. There is one way that I can see that I could be wrong, though, because eventually the input and the output of these models are going to be audio, right? And I have actually seen demonstrations of audio language models working inside Google, and of course you need a lot of compute to get that working. It takes a lot of training, but it definitely seems to work better because going from audio to text through the language model then back to audio, you lose a lot of nuance. But when you're talking to these audio level language models, you can hear sort of laughing or breathing, and it's a much more sort of real experience. So, we might even skip over character level and go straight to audio if there's enough compute. I don't know.
Yeah, that makes sense. Thank you. Right. We got a question from YouTube, and I'm going to read it. So, do you have any ideas on? Oh, sorry. Do you have any ideas on how we should set the number of dimensions of character embeddings to preserve the meanings? Should it be larger than those of words embeddings? That's the question. Thank you for the question.
Yeah, I think that's a research question. I can see why people might think it's one or the other. I mean, you could probably argue that dimensions can be smaller because there are fewer characters. But you can also think, oh, maybe it needs to be bigger because there's fewer characters, right? And there's more we need to represent. My intuition is they should be smaller, right? And the more time steps is what allows the transformer to sort of build up the high representation. But yeah, research is needed to answer that question fully, I think.
Yeah. Thank you. Any other questions from audience online?
Okay, thank you for your speaking. And I wonder what do you think about the multilingual ability will by character level tokenizer will do to the language models? I mean, if you build a language model that basically Japanese character level tokenized, and how do you think it will handle English? Because the English character is not basically in the vocab of the tokenizer, right?
Yeah, that's a good point. But word level has the same problem, right? So the English tokens and the Japanese tokens don't overlap. And I think another direction I would like to research is, when you train on both languages, does the high-level representation of something end up in the same part of the model for different languages? And I can see that that might be harder for character level, right? Because it takes longer for a character level to learn to build up these high-level concepts. And by the time it learns these high-level concepts, maybe it would be difficult for it to put those high-level concepts in the same part of the concept space for both languages. So yes, it's a worry, and again, it's a research question that I'm very interested in, and I'm going to try to find out.
Okay, thank you.
Any other questions? Oh, I got a comment from YouTube, so I'm going to read. So the question is it possible to extend the character level language model to incorporate paralinguistic information, such as intonations, stress, etc., which might convey some emotional information? So that might be related to your comment before.
Yeah, that idea has not occurred to me before, but I guess it would be sort of a halfway house in between character level and going full audio.
Mm-hmm.
So yeah, I can imagine maybe taking some sort of representation from an audio model and then tokenizing that and seeing if that helps it understand a few things. Yeah, I like the idea.
Thank you. Okay, maybe the last question probably from the, I got one comment from YouTube. The question is, Japanese sentences contain other languages like English. How to deal with those language? Maybe multilingual, sentence containing multiple languages.
Well, this used to be a big problem, I think. But I think the thing about modern large language models is that they're powerful enough to cope with this already, So before, if you were training a translation system, you'd have translation pairs. But in the wild, you do get examples where people are sort of mixing two languages together, and of course the translation system would completely fail. But these large language models, because they learn translation as sort of a side effect, they do seem to be able to cope with these sort of mixtures of languages. So I actually think this is a strength of the latest technology.
Right. Yep. Thank you. So I think if there's no any other questions, let's wrap up and let's thank the speaker again.